So today we'll be taking a look at DramaBox, brought to you by ResembleAI, the makers of Chatterbox. Now, I do love Chatterboxes, don't they? It's just really funny because we did cover Chatterbox in a previous video, and I'll be dropping the link to that video in this video description. And it's by the same AI lab, so it's just funny that they made another one with the box at the end. Anyways, let's just begin. So in this video, we'll be focused on DramaBox, but this video is the first part of a three-part series where we're going to set up a commentary engine. Now, if you've watched sporting events, you can actually hear a commentator speaking and describing what's going on the field or on the track, or let's say in the ring or whatever. So in this video, we'll be setting up a commentary engine, and this commentary engine is going to be made up of two parts: the video understanding or video processing model, and also the text-to-speech model. The text-to-speech model is basically going to be the voice of the commentator. Now, that's where DramaBox comes in. DramaBox is an expressive TTS with voice cloning, as you can see. DramaBox is a prompt-driven TTS where the prompt itself controls everything: speaker identity, emotion, delivery, laughs, size, breaths, pauses, transitions. Now, the cool thing about DramaBox is that it supports both voice design and voice cloning. Now, over here, it actually says an optional 30-second voice reference clones the target timbre. So it supports voice cloning, but it also supports voice design. So speaker identity, when we start talking about speaker identity, emotion, and all this, we are talking about voice design basically, because you can actually describe that particular speaker. And as you can see here, it says the voice cloning part is basically optional. So it's optional to provide a voice reference audio. So if you scroll over to the quick start, as you can see here, it says a woman speaks warmly. Then we get what the woman actually said. So this is basically the speaker description. This is basically what they wrote here, the speaker identity. So as you can see, a woman speaks warmly. So it's basically describes the speaker and also the emotion and the delivery of whatever that speaker is actually saying. And another thing you can see here is that they provided a reference audio, which means the speaker in this reference audio is definitely a woman, because you don't want both of them to actually conflict, because it says a woman speaks warmly. But if you don't provide a reference audio, it's going to just create a speaker, a female speaker, and the female speaker is going to say this. Then over here, as you can see, it says she laughs. Ha ha ha, it is good to see you. So just keep in mind that this is actually structured in a way. So as you can see, this is a prompt format: speaker description, like you saw earlier, the dialogue in quotes, then the action direction, she laughs, like you saw here, she laughs. So it could be she whispers or whatever. So that's something to keep in mind. That's an action direction, and then more dialogue. So everything the speaker is going to say will definitely be in quotes. Keep that in mind also. So let's scroll up and begin. First of all, you can head over to files and versions as usual and download all these. So let me just give you a disclaimer. I'm going to be setting this up on a server. I'm not going to be setting this up on my PC, because this is a very large model, and this model might require other models to run smoothly. So that's something to keep in mind. So it might not just be this size at the end of the day, but I'm going to set this up on a server, and that server supports CUDA. But if you want to set it up on your PC, you can also follow along. All you have to do is change the device. If you're using a MacBook M1, like if you're using any of the M series, you can change the device to MPS. And if you want to just run it on your CPU, you don't want to use MPS, you can just switch it to CPU. So everyone else can actually set it up with CPU if your PC or your GPU does not support CUDA. Just keep that in mind as we move forward, because I want to set up the whole commentary engine on that server, because the video processing model also would not be able to run on my PC, but I want everything to be able to run seamlessly without any problems. So this is basically an experiment for me. Let's just continue. So once you've downloaded the model weights, you can use Hugging Face Hub CLI to just, you have to copy this and use Hugging Face CLI to download this repo into whatever directory you like. But it's better to always set it up on your project directory, because that's what we actually did. So another thing to keep in mind is that I did set this up with their GitHub repo. So since I'm actually setting up a commentary engine, though we're going to be trying out DramaBox in this first video, we're going to play around with it like we always do before creating the full commentary engine. What I'm going to do is clone this repo. I'm going to clone it into the projects directory, and all our testing for DramaBox is going to be done in this particular folder that will be created once we clone this repo. So keep that in mind. Before we head over to our IDE, do not forget to like this video if you're enjoying it, and do not forget to hit the subscribe button, hit that bell notification icon so you'll be notified when I release the other part of this video series. So if you want to follow along, do not forget to hit that bell notification icon. Anyways, let's head over to our IDE. So as you can see, we have our project set up in a very weird way. Over here, we have our DramaBox folder, but that's not where my virtual environment was set up. It was set up in the root directory of the workspace, just the workspace directory. That's where it was actually set up. So these two folders are there. But for DramaBox, since we're actually trying this out first, before we integrate it into the whole thing, I did clone this, and this is the command you need to run. As you can see, git clone, and this is your GitHub repo. So make sure you do that, and once you've done that, you have to enter into that particular folder, and that's what I did already. And to download this model, if you don't want to do it manually, you can just run this command, hf download this, and I pointed it to the models/DramaBox folder. And sorry, that's not that. That's what we have here. DramaBox. And once you're done downloading DramaBox, you would also need the Gemma model. If you don't want to go through all this hassle, this model will be automatically downloaded for you if you don't follow along, like if you don't change anything in the model downloader.py. Because that's what we are going to do next. Since we are setting this up on our server, I don't want this to be moved to the catch directory. So if you want to set this up locally on one project directory, that's the reason for setting it up this way. That's the reason for downloading the model into that particular folder. So once you're done downloading the DramaBox model, you will also need to, let's see, download the Gemma model. And this is the Gemma model they used. Now, if you're using a CPU, I don't think you can actually run a B&B 4-bit model. I have actually tried. I don't know if the Transformer Python package has actually improved or something. But back then I could not actually do it on my PC. You can actually try it out, or you can use, I think you might be able to use the normal model that's not basically 4-bit. And if you use the normal model, you would have to actually make some adjustments to the app.py. Because if you head over to app.py, you can see this is how they set it up. It's B and B 4-bit true. So just keep all that in mind. So as you can see, we're pointing it to the models/Gemma folder. So this is the model. And once you've done that, you would also need, since you actually are in the GitHub repo, you would need to install the requirements.txt to get everything set up. And once you're done, we can begin running this. But first, let's make some changes to the source model downloader folder. Now, since we've downloaded this onto this particular folder, I don't want it to, run this snapshot download. So I'm going to comment this out. So I'll make all the necessary changes and you can follow along, but I'm going to speed up the video a little bit. So we're going to run app.py, and all the changes I actually made was so we can actually use the model which we downloaded here. So if you don't want to actually do that, if you don't want to set it up this way, then you can just ignore everything I did in the model_downloader.py, because it will automatically pull this model and send it to your catch directory. But if you want to keep everything in one place, and I advise keeping everything in one place, where if you just delete this project, everything is gone. That's the reason why I actually made all these changes. Now, let's just run python-m app. While this is running, like I said, if you want to run this on your CPU and it doesn't support BNB 4-bit, you can just change this to false. And you can also change the device to, let's say, CPU if you want to run this on your CPU, or MPS if it actually supports MPS. You have to actually try it out. It might support MPS. What else? And also, if you're running this on an MPS device, you can change this D type to float32. It's basically up to you. It will run faster, but it will consume more resources. So keep that in mind. If you're running it on CPU, then you can just leave this as the float16. You don't need to do anything else. Anyways, as you can see, it's loading the checkpoints. And if you scroll up, as you can see, it just got the model from where we actually pointed it to. Anyways, Once it's done loading up the model, it's going to start up the graduate server. Okay, I think this is a local URL and this is a public URL. So the reason why we have a public URL is because of this. It's set to true. Since it's set to 1 or true, that's the reason why we have this public URL. And since I'm running this on a server that's separate from my machine, if I set this to false, I won't be able to access this public URL, and I won't be able to see any, I won't be able to access the Graduate web app. So keep that in mind. Now let's click on this link and head over to our browser for testing. So we have everything open up here. Let's try one of their examples. Let's try the monologue. So as you can see, it's generating the audio. And this is the voice reference they passed in. So it's a shadowy villain speaks with cold menace. You have entered my domain, mortal. He chuckles darkly. Such arrogance would be your undoing. Then his voice rises with fury. Kneel or be destroyed where you stand. So let's hear it.
You have entered my domain, mortal. Such arrogance will be your undoing. Kneel or be destroyed where you stand.
That was not bad at all. That was not bad. So let's actually hear the voice reference.
And if self-preservation is an instinct you possess, you better fucking do it and do it.
That was close. So anyways, let's paste something. So the 30-year-old male narrator is precise and dry when speaking, as though reading from an engineering report they find genuinely interesting. Then he says this. So let's see what happens. We'll still use the same voice reference. So it's supposed to say all this.
For the 30-year-old male is precise from an engineering report they find genuinely interesting. The model conditions on both text and prior audio context. Each generation takes the previous turn's output as input. The voice doesn't reset between responses. It carries forward.
That was nonsense. It's just said this part, even though this part was not actually in quotation. It actually said this part, which means it didn't actually take into consideration this voice or the speaker description, which we actually passed in. It just said this. That was actually weird. But it also said this, and it also cloned the voice, which was actually really good. And let's take this off and we'll say, sorry, we won't select anything. Let's just generate. So it's done generating the audio. Let's hear it.
The model conditions on both text and prior audio context. Each generation takes the previous turn's output as input. The voice doesn't reset between responses, it carries forward.
That was not bad. That was not bad. It actually took in the speaker description and it also said everything exactly as we actually instructed. The 30-year-old female narrator speaks softly. The gender was in consideration and also the age, and also how the speaker was actually speaking, which is actually cool. So let's try something. Yeah, let's run this again. Let's hear it.
The model conditions on both text and prior audio context. Each generation takes the previous turn's output as input. The voice doesn't reset between responses, it carries forward.
Not bad. He didn't actually laugh maniacally. anyways, anyways, we're going to try something else, and this time we're going to add a voice reference. So this is the scene prompt we're going to be passing in, and let's select the audio. I'm going to select my own voice. Okay. Let's select us no wave, and so let's hear what it sounds like. Please find attached the comprehensive list of issues we noticed while reviewing the. So that's basically my voice. Now let's generate. Let's play it. In ceremony. The interesting thing about this model isn't what it does in isolation. It's what happens when you wire it to something it wasn't designed for. That's where you find out what it actually is. Okay, so let's clean this up. Okay, so first angrily, then he pauses and sighs deeply. He continues, and then speaking quickly, he says, so let's see what happens. Because it actually got my voice a little bit, so even though it had that weird accent, but it actually did a really good job cloning my voice. But let's see what happens since I have actually added some expressions. So let's hear it. The interesting things about this model wasn't what it does in isolation. It's what happens when you wire it to something it wasn't designed for. That's where you find out what it actually is. Still speaking really softly. So let's try something different. Let's remove the voice reference. So we'll see if the pace is actually coming from the reference audio. So we're going to say, so let's just send it. We'll see what happens this time. Maybe it will actually, be more expressive since it's not using the voice reference audio. So now it's done. Let's hear it.
Are you fucking insane, Heater Youth? Are you fucking insane? The interesting thing about this model isn't what it does in isolation. It's what happens when you wire it to something it wasn't designed for. That's where you find out what it actually is.
That was not bad. It was way more expressive than when I actually passed in a voice reference. But it still had some artifacts. It repeated, are you fucking... Sorry for my language. But it actually repeated this twice. So let's do something different. Let's try cloning Optimus Prime voice. And so let's pass in the text and let's select the audio file. And I think this is Optimus. So let's hear what this sounds like.
And just when all hope seemed lost.
So this is basically a dubbed audio. Let's generate. So let's hear it.
We did not come to this planet as observers. We came because what happens here changes what comes after. That is not a small thing.
Not bad. Quieter. It actually got a little bit quiet, but that was not bad at all. So let's try again. So just keep in mind that there are inference settings here that you can actually play around with. So it's definitely up to you to actually play around with this, but I won't actually be using any of that since that's not the focus of this video. So you can also play around with this. There are very simple descriptions here so that you can follow along. So let's hear what it sounds like. Honestly, I just want to hear what it sounds like because I've never heard Optimus Prime on show.
I'm sure about anything he speaks. We did not come to this planet as observers. We came because what happens here changes what comes after. That is not a small thing.
He basically pouts instead of clearing his throat. So let's remove the 4 times and let's say he feels. Okay. So let's send it again. So let's hear it.
I feels unsure about anything. We did not come to this planet as observers. We came because what happens here changes what comes after. That is not a small thing.
He didn't actually clear his throat, he just kind of chuckled. Honestly, don't know what else to actually change here because it's basically missing a lot of things. Sometimes it actually says the prompt, like the speaker description, and also says this, but it's really weird. This has actually happened multiple times, not just with the Optimus Prime audio. Previously, we actually tried cloning my voice and it's said this out loud. So it actually the model still has some kinks, honestly. Anyways, let's move forward, and this time let's dive back to our IDE and begin our setup for the full project. And once we are done setting up the TTS method that's going to be powered by DramaBox, that's basically going to be it for this video. So the method is just going to take in the text and some other parameters and generate the audio. So for my final thoughts about this model, I do think it's a good model, but they still have a lot of kinks to actually work out when it comes to the audio generation, because the quality is not there yet, and also it generates artifacts. And another annoying thing is the voice design is really great, but sometimes it actually contaminates the dialogue with the voice, the speaker description. Basically, it takes some part of the speaker description and passes it in as dialogue and then generates the audio, which is really, really terrible. But you can actually play around with the inference settings. You can play around even with the long form options. That's something you can play around with. And while I'm actually setting it up, I'm going to adjust most of those parameters and see how it actually performs. So let's dive into our IDE so we can begin setting up the commentary engine TTS method. So let's copy the section that actually handles loading up the model. So instead of doing it this way, I think what we're going to do is really simple. We're going to create a method to load models. So we're going to place a voice reference audio there, and we're going to name it voiceref.wave. So that's what we're going to pass in. It's basically optional. So we're going to do this or. So this is what we're going to do. So let's return this. I think we should actually automatically play it. So let's create a play method. I don't think we actually need this audio file. So this audio path, I mean. So let's just pass for now. We're going to paste in the content of this particular method shortly. I don't think there's anything else. All we can do is run self-play here. And all we're doing is passing in the output. So I called the wrong one. So let's do this. So first of all, let's paste this in, and we're going to try this and see what actually happens. So let's install Pygame, because we're going to be using Pygame Mixer. And I think we should keep this. So let's just remove the audio file automatically the moment it's done playing. And we're going to change this to, I don't think we need to pass in the output here. So we can just do this basically. So since that is done, the next thing we're going to do is write a simple minpy, and we're going to import everything. So let's just pass in our text prompt. Let's remove this. This is not what we want. And we're going to pass in something. I think we're going to pass in something that we actually used before. So let's pass this in. We're going to change this to a single quote since we need the double quote inside. So let's just say so this should automatically play the audio. Since we are calling this, we are instantiating this particular class, and we are also calling this TTS method. I think that's what it's actually saved as. Yeah, so that's what it's saved as, and the model is being loaded here, and we are declaring the TTS server here, and we are using it here to generate from file. Basically, since we actually returned this, the TTS server, so every method that is actually there is we can actually access it. So let's just run this and see what actually happens. I think we should have even put this up there. We should have just declared this up here since we are clearing everything here. So let's do this. Let's run main.py. Let's see what happens. So since we are not passing in any voice reference, it should just pass in this blank stuff. So let's see what happens in the end. Now we should have actually enclosed this in a path. The problem is actually loading up the model. Let's try sending this here. So let's try again. So I made another mistake, and the reason why I'm actually running into issues like this is because this IDE currently is not highlighting the syntax. So when I make a small syntax error passing a variable that doesn't actually exist, it won't highlight it because this was actually set up on the server. So for whatever reason, the extensions are actually set up to highlight the syntax isn't actually doing anything for a code that's set up on a server. So that's the reason why. Now it's actually working, I think. And this time it should load up the model and generate the audio, and we will find the output in outputs folder. It actually generated the audio and saved it, but it didn't play it. So what we're going to do now is listen to it.
We did not come to this planet as observers. We came because what happens here changes what comes after. That is not a small thing.
Couldn't open audio device. So I absolutely forgot we were running this on a server, and these servers have no input-output audio devices. Like, they have no audio devices at all. So it won't automatically play. But this problem doesn't affect our commentary engine in any way, because our commentary engine is going to have a web UI, so it will automatically play the audio using our web browser. We have no problems with that particular setup. But for this particular test, since we already played our output.wave, that's basically going to be it for this video. So if you want to follow along and see how we get the commentary engine up and running, then do not forget to subscribe, hit that bell notification icon so you'll be notified when I release the next part of this particular series. And do not forget to like this video if you did enjoy it. Thank you for watching. Have a nice one.